Today we're going to be talking about graphing linear inequalities in two variables. That's not much different than what you've been doing, but now instead of just saying something like x is less than 3, now we're going to have x plus y is less than 3, or something like it. Not necessarily just that, but definitely something like it. So let's go ahead and take a look. An ordered pair is in the form x comma y is a solution, right, of a linear inequality if the inequality is true. That means you have to actually read what it's saying and make sure that what it's saying makes sense when the values of x and y are substituted into the inequality. So really, what's that mean? Well, why don't we just take a look at a problem. We have example 1. In the ordered pair, is the ordered pair negative 3 comma 7 a solution to the inequality 5x minus 4y is less than negative 20? And remember, the inequality is always written as, or not the inequality, but the ordered pair is always written as x comma y. So all we have to do is, just like anything else, take this x and this y and substitute them into our inequality and see if it works out and if what we get is true. So let's go ahead and give that a try. We have 5 times x, but so I'm going to be replacing x with negative 3. When I replace a variable, I need to open up parentheses and put my negative 3 inside of there. And I have, from that I'm subtracting, so minus 4 times y, but I'm also replacing y. So again, replace it with parentheses, and I'm going to replace y with positive 7. I want to see, is that going to be less than negative 20? So all I really have to do is take a look at the left-hand side of the inequality, simplify it, and see if what I get is something that's true. So I have 5 times negative 3. That's going to give me negative 15. Minus 4 times 7 is going to give me 28. And simplifying even more, negative 15 minus 28 is going to give me negative 43. So now I have to check, is negative 43 less than negative 20? It is, so this is true. Negative 43 actually is less than negative 20, so this is true, and since this is true, yes, the ordered pair is a solution of that inequality. Let's take a look at another example. We have the example, number 2, is the ordered pair 2/3, comma, negative 3/2 a solution of the inequality 3x minus 2y is less than or equal to 5. So again, the ordered pair is always x comma y, and all we have to do is now just plug this in, plug our x in, or substitute our x in, substitute our y in, and see if our inequality is true. So let's see, we have 3 times, it's 3 times x, so I want to put it in parentheses, and I want to replace x with my x value from the point, which is 2/3. And from that, I want to subtract, so minus, oops, I want to be black on that, minus 2 and times y, so I'm going to be replacing y with an actual number, so again, put it in parentheses, and I have negative 3 over 2. I need to check to see, is this less than or equal to positive 5? So let's see what I can do. I have 3 times 2/3. This, the 3 outside of the parentheses and the 3 in the denominator, I can actually just cancel those out. So 3 times 2/3 just gives me 2 minus 2 times negative 3 over 2. So again, the 2's will just cancel each other out or divide to 1. So I have 2 minus negative 3. And I want to see, is this less than or equal to 5? 2 minus negative 3, some of you call this keep switch switch, but subtracting a negative means I'm going to be adding a positive. So now I have 2 plus positive 3, which of course is going to give me 5. Is that less than or equal to 5? Well, it's certainly equal to, so yes. The answer for example 2 is yes. This is the point 2/3 comma negative 3/2 is a solution to the inequality.